All right, so we now have this idea that mass can curve space. And then, as space is curved, this will lead to accelerations that we understand as gravity. However, going back to this idea of mass curving space, well, we can use this to help us understand the shape of the universe. I realize talking about shape seems really weird, but mass curves space. And so if there's, depending on the amount of stuff in the universe, will actually determine how it is that space itself is curved, which is going to give us the shape of the universe. Okay, so the overall shape of the universe is going to be determined by the total amount of matter and energy within the universe. Now, if the universe has too much stuff, what we call the energy density, then gravity is actually going to cause it to kind of wrap back in on itself. Okay, now, the way that we could actually see this is by the bending of light. Okay, so what happens is we have two light rays that begin as parallel, but if the universe has too much stuff and it wraps back in on itself, then these lines that begin as parallel will eventually converge. They'll actually meet up together. Now, you may be thinking that you learned in geometry that if two lines are parallel, they'll always remain parallel. And that is true on a flat sheet of paper. But we are no longer dealing in flat space. Instead, we're dealing with a sphere. So, as an example, imagine the Earth. If you and a friend are standing on the equator of the Earth, both facing north, then you start out facing parallel with each other. You're both going north. Then as you begin to walk, eventually, no matter where you start, your two paths are going to meet up. All lines that begin as parallel at the equator will meet up at the North Pole. These lines all converge at the North Pole. So because it is a sphere that does this, that's the shape that does this, this is what we refer to as a spherical universe, sometimes referred to as a closed universe. Okay, so in a closed or spherical universe, lines that begin as parallel will eventually converge. Another possibility if there is not enough stuff in the universe. If there is not enough stuff in the universe, then we get the opposite curvature. Then everything moves away. So lines that begin as parallel will eventually diverge. They'll actually split apart. The shape that causes this is this kind of weird saddle shape. It's what's referred to as a hyperboloid. So this is known as hyperbolic or open space, hyperbolic or open universe. In a hyperbolic universe or open universe, parallel lines will diverge. Now, the very last possibility is if the universe has the exact right energy density, if it has the exact right amount of stuff, what is referred to as the critical density. If the universe has the critical density, then space is flat. Then, instead of things converging or diverging, lines that begin as parallel will always remain parallel, which is exactly what we see on a flat sheet of paper. So this type of universe is sometimes referred to as a critical universe because it's got the exact right amount, also known as a flat universe because it is like a flat sheet of paper. So in a flat universe, lines that begin as parallel will always remain parallel. Now, based off of all evidence that we have, this suggests that the universe is actually flat. We live in a flat universe. What's nice about that is the geometry you learned with a flat sheet of paper holds for the entire universe. Well, unless you get too close to things like black holes. Then stuff goes weird. But don't worry about that. Now, the universe actually being flat, having that critical density, means that we know how much stuff should be in the universe. But this actually leads to a problem. And that problem is when we actually look out and we add up all of the stuff that we see and everything that we know about, it only adds up to 4% of the total universe. Okay, so ordinary matter, this is the stuff that we interact with, this is the stuff that's on the periodic table, this is the stuff that we know about, only makes up 4% of what we need for the universe to be flat. Now, some of the rest of what the universe is made up is dark matter. Now, what we mean by dark matter is that, in part, it is dark in that we do not know about it. No one shined a light on it yet. The other piece of why it is dark is that it does not interact electromagnetically. So if you remember back when we were talking about electricity and magnetism, we mentioned that light is an electromagnetic wave, or is caused by electromagnetism. So if this matter does not interact through the electromagnetic force, it cannot interact with light. It does not absorb light, it does not give off light. So it's not just dark. In my opinion, a better term would actually be invisible. You cannot see it using light. So if we can't see it, how do we know it exists? Well, the way that we know that it exists is because of gravity. It still has mass, which means it's still curving space, it's still pulling things together. So we can actually kind of use the ideas of what we learned in the solar system. So in the solar system, we mentioned that the closer a planet is to the sun, the faster it's going to orbit. The farther away the planet is from the sun, the slower it orbits. Well, we can actually use a similar idea and apply it to the entire galaxy. What we find is out towards the edges of the galaxy, we should start to see stars slowing down, similar to what we see for planets within our own solar system, just because there's not enough matter there to keep them going really, really fast. However, we see that they are not slowing down like we would expect. Instead, they've actually kept the same speed as closer into the middle of the galaxy. So what this suggests is that there's more stuff out there than what we can see, which suggests that there is actually dark matter. Based off of what we can tell, our galaxy, which is made up of what we call luminous matter, this is the normal, ordinary, everyday matter that actually is able to interact with light, is at the center of an overall dark matter halo. So we have this region of dark matter that surrounds our entire galaxy. So what is dark matter? We actually don't know. We have very strong evidence that exists, not just from how it is that stars in our own galaxy move, but actually stars in lots and lots of galaxies, and even the way that the cosmic microwave background is shaped suggests the existence of dark matter. But exactly what it is, we still don't know. We're trying to figure it out. We've been doing experiments trying to find dark matter for almost 50 years, and we still haven't found exactly what it is, although we have very strong evidence that it does actually exist. Now, the other question we have is, so what's the rest of the universe? Well, using very careful measurements of distant galaxies, we actually see that the expansion of space is getting faster and faster. In other words, the expansion of the universe is accelerating. Now, we don't know what could cause this acceleration. The only force that we know of that can act on a universal scale is gravity. And if you remember, gravity always pulls stuff in. So that would suggest that the expansion should be slowing down, and yet we know that it is not. So we don't know exactly what is causing the acceleration, but to make ourselves feel better, we give it a name. We call it dark energy. And it's this dark energy that makes up the remaining 73% of the mass energy of the universe. Okay, so this acceleration of the expansion rate started about 7.5 billion years ago. So not quite, just over half the age of the universe. So we can actually figure out the composition of the universe. Most of the universe, 73%, is dark energy. A lot of the remaining is dark matter at 23%. Okay, now remember, we don't know what dark matter or dark energy is yet. We see their effects, and we even understand kind of their properties, but we don't know exactly what they are. Then the remaining stuff is actually of stuff we actually know. Most of it is made up of free hydrogen and helium. About 0.6% is made up of stars. 0.3% is made up of tiny subatomic particles referred to as neutrinos. We haven't really talked about them, but they are still considered normal matter. And then just 0.03% are of elements heavier than hydrogen and helium. In other words, most of the universe is dark matter and dark energy, with just 4% making up everything else. And the stuff that we actually know is really small. Now, the eventual fate of the universe is determined by what it is made of. So we've seen that the universe is 73% dark energy, and we know that dark energy is causing the expansion rate of the universe to accelerate. So this leaves us with two possible scenarios for how the universe is going to end. One possibility, so in this graph, we're looking at how large the universe is. So down here, the universe is small, up here, the universe is large, and then along the bottom, we're looking at time. So at some point in the distant past, 13.8 billion years ago, we had the Big Bang, which caused the universe to begin to accelerate. Now, for a time, the universe actually did slow down, caused by gravity, until about 7.5 billion years ago, dark energy was able to become stronger than gravity, leading to the expansion of space speeding up. Now, two possibilities. We have the heat death. Assuming that dark energy remains a constant force, this means that the expansion of space is going to continue at a ongoing rate. This is going to cause galaxies to continue to move away from each other, and eventually, they'll be moving far enough and fast enough away from each other that they'll no longer be visible. We will no longer be able to see other galaxies from our point of view. Then, within galaxies themselves, eventually they'll use up all of the interstellar medium so that no new stars are able to form, and then the stars that did form are going to slowly die out, starting with the hottest stars going to the coolest stars, until the very end fate of the universe is going to be perfectly black, perfectly cold, and completely depressing. This is what we often refer to as the heat death of the universe. Another possibility that is sometimes considered is what is referred to as the Big Rip. In this case, the expansion of space caused by the accelerating universe by dark energy gets stronger and stronger and stronger. So not only will galaxies get pulled away from each other, but this pull of the expansion of space caused by dark energy will actually be able to begin overcoming gravity. What that means is that galaxies, which are held together by gravity, are going to get ripped apart. Then, as it continues, solar systems. The expansion of space will be so fast that solar systems get pulled apart. Then it'll be so fast that planets get pulled apart. And then molecules get pulled apart. And then atoms get pulled apart. This is what is referred to as the Big Rip. Personally, I find it kind of terrifying. I much prefer the heat death because that's going to be a really, 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 really long time before that ends up actually happening. The Big Rip, if it's what's going to happen, is actually terrifyingly soon, only a few billion years away. Yeah, I realize I'm talking billions of years. I'm not going to live to see it anyway, but it's still a really scary idea. All right, here is our fifth clicker question. How much of the universe is made of stuff we still don't understand? A, 4%, B, 27%, C, 73%, or D, 96%. Go ahead and think about it, and we'll discuss in just a bit. So how much of the universe is of stuff we don't know what it is yet? The answer is dark matter and dark energy. We still don't know what those are. We are fairly convinced that they exist based off of observational evidence, but we don't know what they are. So the correct answer is D, 96%. We only know what 4% of the entire universe is actually made of, and the rest is that 96% of dark matter and dark energy, and we don't know what it is. Now, that may sound like bad news, but it's actually awesome because it means that astronomers still have jobs.